In this screencast are the solutions for the constructions homework, which I believe is worksheet 2.6b. This is for the accelerated class. So for the first problem, you're asked to construct CD congruent to AB. For that, you would do the generic copying a segment construction. So start with a segment that is longer than the one you're trying to copy. And grab your compass. What you want to do is mark off a segment that's the same length as your original. So if you open your compass to be the size of your original, testing, watch, knew it. So if you open your compass to be that large, then you can make a circle there. Technically, you don't have to. They're going to be testing all day, I'm sure. And then you want to mark off that same distance on the large segment that you created. And now you have a segment that is, let's call it CD, that is just as long as the one that you started with. Whoa. Mess up. You know what I meant. That one. Just as long as the one you started with. Alright, and you can find that video elsewhere. To construct a segment that is the length of two segment lengths added together, you're going to start with a segment much longer than what you think you'll need. And you're going to copy these two segments end to end. So let's copy TR. Alright, let's go with green. So we're going to copy length TR and open your compass to that length. This is approximate. And you're going to mark that distance off on your segment. Remember, you're not going to just make an arc. You're always going to make full circles so you can see how the circles and the segments interact to form the figures that you're making. Then you are going to mark off this next length. Okay, so let's see what the length is here. It's about that right there. So you're going to mark off that length starting where you just ended off. Okay, oops. So you make your circle centered at that previous endpoint. And now the radius of the blue is the length of PS. The radius of the green is the length of TR. So from one end to the other, you're going to have GH. Right, from here to shining here. Next, you want to construct a segment that is AB minus half of TR. So think about how you might be able to do that, or think about times when you've subtracted segment lengths. You've probably subtracted them in situations where you had, let's say, that, and let's say the entire red segment was, I don't know, let's say it was 10 inches. Say the entire thing was 10 inches. And this green segment, let's say that that was 4 inches. If you were asked to find the length of the red, you would do 10 inches minus 4 inches. Here, you're asked to find the length of a segment minus some other segment. So you could have a similar situation to this. And that'll be one way to do it, is to create a similar situation to this. Right, so let me put this down. Yeah, let me just shrink this. There it is. I'll put it up here, down here. Okay, so AB minus TR. So you want to create a segment that's longer than what you think you'll need. Let's say that. and we're going to create KL. So we're going to start at K and go to L. So let's say K is there. We're going to make AB. Okay, so let's see how big AB is. All right, open up your compass to AB. It's approximately that long. You want to mark that distance off on your segment. Okay, so that segment now, I'll make it blue, that is the same length as AB. Now you want to subtract half of TR. So you're going to have to find half the measure of TR. Think about how you're going to find that. That's right. You're going to do a perpendicular bisector. You've got a bisector, you've got the midpoint. So the bisector, make a same size circle at each end. Make sure you opened your compass more than halfway across TR so that your circles will intersect. And draw a line through those two intersections. And now you have half the length of TR, which is that right there. So that's half the length of TR. So what we want to do is similar to what you had down here. So I'm going to take that length. I'll put it here. Okay, so now this red segment, which is half the length of TR, if I subtract that, if I take the blue, the large blue, it's down here, and I subtract the red, then I'll be left with this green. So I guess I'm going to have to relabel that. What we're left with, the green, is supposed to be KL. So I'll just rearrange that a little bit. Alright, so that green segment is KL, which is AB minus 1/2 of TR. For the next one, construct an isosceles right triangle. Sometimes if you just look at what one of those isosceles right triangles looks like, you might be able to figure out how to construct the parts of it. So here's an isosceles right triangle, or at least a decent approximation. Okay, so what do you notice in there? You have a right angle, and you have some congruent segments. So think about how you can construct a right angle. Think about how you can construct congruent segments. So I'm going to start with a segment larger than what I need, and I need to create that perpendicular. So I will do a perpendicular bisector. Let's see. Grab my compass. Alright, now I'm not going to bisect this entire thing. You know what? I'm just going to start. I'm going to start from here, and I'm going to make my segment that big. That's the segment I'm going to bisect perpendicularly. So, circle centered there, and a circle centered here. Get that a little bit more accurate. Doesn't want to move. There we go. Alright, you put a line through those intersections, and then you have perpendicular. Okay, so now we have the perpendicular part all done. So you can probably see this coming together now. Alright, and our original segment that we were working with looked like this. Okay, so let's see. Now we need this segment here to be congruent to this segment here, the two legs. So let's say, let's use blue here. So let's say that I want it to be, my isosceles to be that big. I want one of the legs to be that big. It doesn't matter what size they are. Just move this all down. It doesn't matter what size they are. So let's say that big. So if I make this, every radius of that blue circle is going to be the same length, which means that this radius that I'm about to make is the same length as this radius. You connect those two radii, and there you have your isosceles right triangle.